Welcome everyone to now hopefully a fine live stream with audio. Also another day, probably sometime soon, unsuccessful one-man distribution guy rewrites, puts audio in Rust or something. But anyway, today's topic slightly different. Who doesn't know this? You get a fancy new machine, embedded board, vintage Unix workstations. You wanna network boot it, and all you get is request, unsupported request stuff. Yeah, so I knew this particular issue for quite some while, and you will find, actually could have opened it, you will find many documentation, simply network boot, let's say SGI whatever, maybe with Linux, but most stuff usually recommends some TFTP, HPA or something, and other regular DNS stuff. And the issue with that is that that code is even more vintage, and often when on my first years on Linux 20 years ago, the stuff was, I usually spent like a day fiddling with TFTP, HPA, and then it still didn't work. So yeah, since then, fingers burned once, never touched this stuff again. So for the regular stuff, we and probably most other people in the small home office run something like dnsmasq these days. The not as complex to set up and somewhat readable, but we will see in a moment, also C code, but it has some limitations. So although it works quite fine for and probably is run on many cheap plastic router stuff from your access point goodness, the issue with this TFTP implementation, as you see, leaves a little bit to be desired. And I knew this already from network booting other machines, Hewlett Packard precision architecture and stuff. One thing is that for this case it doesn't even work nicely, because this dnsmasq always forces the configured file, which probably, anyway, the configured file from the etc dnsmasq conf to the client. So the client mask, hey, the client may ask, give me IP32 or something, or arcload, and whatever is in the dnsmasq config is then forced down the client throat, which is not very nice. And so arcload, not arcload, that was network. And I patched this already, it's not yet upstream, but I have here some no file override patch that is a little bit, but that's not, maybe we take a look at the end. This is, it's like, yeah, matching incoming file name. I have here some global hack, static hack variable to capture what the client requests, and then instead of forcing his option file name, if a little bit hacky, but today the topic is something else. So the other thing is also, yeah, invalid request, what the heck is going on. So let's take a closer look, which obviously I've done already. So let's RC stop here, or also that's probably, hopefully shouldn't lose our live stream. I hope so much to tinkering live on your router in the office in the weekend. Anyway, so this is our custom, not system installed, but locally custom dnsmasq. Sources here with -d for debug in foreground, and I modified this a little bit and actually fixed it already a little bit. So let's run this again, boot p, and now something more stuff works here, not perfect, but let's take a look. So the issue is, as you see, for this more fancy, more sophisticated configurations, we need more than one file name. So for this, the statically configured file name in dnsmasq doesn't deliver anyway, because we need not only arcload or whatever, grub2 in your case, but also grub2 or arcload might then ask for, hey, give me the VM Linux, give me the init.rd, and if there is only one hard-coded file name in the dnsmasq conf, then yeah, YOLO, whatever. Anyway, so let's see, why does it work now and what have I fixed? So I added there, you could also run Wireshark or TCP dump, but that is a real router and I'm like, yeah, not traffic dump that too much now. Also traffic dumping is always nice and recommended, but I simply added here some printfs in there to hex dump the request, and this is the first request. Yeah, so this is the first request. Also, do I leak it too many IPv6 addresses maybe? Anyway, so this is a hex dump request of the request that this vintage Unix firmware, but it doesn't even really matter, could also be a latest and greatest embedded board, gives us. So the request is 0. So this is like hex and the character, like printed as character to better read what's going on there. So this is 0, 1, and then arc load here obviously dot ecof 00 something, then octet something. So if we take a look here in some fine nice standard like this one, we can decode this request here. And so there are opcodes. This is how it works with opcodes and block data. Where's the request? Here's a request, read request, and write request. This is how simple it works internally. Just 2 bytes. So the opcode here is here 2 bytes, 0, 0, 0, 1, but basically 0, 1 simply, and 0, 1 is opcode. This is 1. And this is read request, file name 0, mode 0. And what do we got? So we got here our opcode 1, then the file name, which, yeah, the file name that dnsmasq nicely ignores. Thank you very much for that. Then a 0, wait a second, where's the 0? Then the 0, then octet, then a 0, and what else did we have here? A mode 0, so, wait a second, file name, mode, so file name 0, octet 0, and then here is a little bit of more stuff, so 0, 0, 0, 3, 1. And that is some random garbage. Not I could disassembly the SGI ARCs firmware another day. Not sure if it always leaks here random garbage. If this is something usable, I have no idea, but that is a problem. And so the unpatched version then errors out with invalid request, and I was debugging, so let's check why. In source TFTP, and the reason I made this video, normally I might not even necessarily made this video, but this is another point of here, C code, everything open coded, fiddling around with pointers, exactly how you're doing, preferably not. And the issue with this code is here, is this parsing of this request. Okay, let's check for our hex dump. This is my hex dump function here, just hex dump pointer length of dumping this out. Here's the packet, and here we are parsing that. And the problem is this parsing, network to host. Here's a packet, so this is big endian reading here of this opcode. If that is not opcode read request, then error out here says unsupported request. So this is a if something I don't like, then unsupported request. Then if not, also yeah, file name, parsing the file name next, and file name mode. And then I was logging here also the file name and mode, and they were null. As I was wondering, why the heck are they null? Doesn't make much sense, right? Because they clearly were here, right? You see them. Turns out, let's take a look at this next function, because certainly that is super amazing, right? Obviously it's written in C, and everyone can write C without an error. Alright, this is already the patched version. We probably okay, let's rename this to patched and freshly untar it and take a new look, because I already modified it. So that is the original function. Parsing, so this is, as you see, used a couple of times here for all the parsing needs. So hopefully that is an amazing parser function, right? So this is original. And so first of all, open coded C code, right? Title of this video, defensive programming. The problem is, well, you should always program defensive. Defensive meaning assuming you get random garbage, right? And So even if there's also, yeah, Apple, Microsoft, Google security, and next local VPN or Linux kernel, assuming it is so nicely formatted like that, like opcode file name 0 mode, and yeah, if you program this very naively and just hope for the best, then usually it out of bounds left and right and segmentation fault and null pointer dereference easily. So what's wrong here? First of all, another prime example for writing stuff in higher level languages, not this let's do all the pointer arithmetic and string handling in open-coded stuff with pointer magic that only the best of the industry can understand. And so if this would be a proper, or a more higher level structured language with support for string, then you could just like parse this here, like next, like a size limited, bounds limited buffer of like even a string, like even Lua of unsuccessful one-man languages. Even in Lua you could parse this nicely, strings with a length, with an explicit length, and that can handle embedded null values here, but not in C. So also theoretically there's string talk, right? Could we do this with string talk delimiter? I think, by the way, breaks. Oh, right, you can't really do it because it's null terminated. Okay, anyway, takes this back. But anyway, so the issue here with this is this line, and nobody has screamed yet too much in the audience, or even still alive. The issue is this, and so first of all, raise your hand, can you read this? And second of all, do you find this bug? And maybe pause this video and see how long. Also, yeah, remember in the 80s and 90s when there were these printed magazines with all this obfuscated C and C++ stuff, and can you find the bug? Maybe pause the video, think about this, and then continue when you found the bug. So we get here a pointer to a string pointer, so double pointer, and here's some thing for buffer and handling the end. And so what this is doing here is it's relying that this is nicely formatted and formatted like this, and includes a 0 at the end, which is it's doing here. So if the end -1, obviously, because the end is actually the end is the full length of the input buffer. So if the end -1, so the end is here, like here, and -1 is this. So if this end of the received buffer is not null, then this arrows out, right? So if this or this or this. So this here is if we reach the end, and this is also, yeah, amazing readable code, right? And amazing amount of comments, aka not a single comment. But yeah, this is how you decipher this. Well, also, how do you decipher this? You think about each expression here and only continue when you understood each of all of those expressions here. So this is the end of the buffer is null terminated. We have because this is double, this is a pointer to a pointer, so a pointer to a string. If we have not reached the end, and the length and the string length of the current string length return, they assign this here. So they simply start with assigning this. Also a little bit funny, they have here yeah, this is slightly funny, right? I mean, why do they even do this? P, do they advance? Okay, because they advance it. So they capture, they save here the supplied pointer because they advance it. But anyway, so this is for passing the next token. They advance this pointer to a pointer there. So they basically advance this pointer to the string buffer. But so yeah, this is the issue. And so as you see, if the not as standard conforming firmware of maybe your latest and greatest embedded board or your good old-fashioned Unix machine does not supply, like it's as simple as random garbage here. So quickly your parsing can break in 1,000 pieces. And yeah, for a test, what did I do in this other? Let's check. Let's move this here to original and move this back to not patched, and then go in back here. And yeah, I think I just removed this, but the problem is, so let's see. So this was good enough for a quick test, as you see. So we should simply check. Oh yeah, so there's another problem. So this, my modification, so for a quick test, I removed here this check, as you see. Somehow also my YouTube stuff doesn't really reload. So I've removed this check, as you can see, but yeah, no, this is more like live, so much to YouTube stuff. But removing this check is of course not error prone. This improves, it fixes our SGI ARCs firmware here, but of course this is a security issue for now. We wouldn't limit this to the end of the buffer. You would think also, yeah, C programming, how fragile is it really? With this check removed, which makes our SGI ARCs firmware here work somewhat, you would think, hey, we still check whether we reach the end, right? But no, wrong, because in the next line we run the good old-fashioned C string lang on this, and this now might not be null terminated. So what we actually would need to do is we probably could rather easily fix this. So in my opinion, the whole function, it is hopeless. It should be rewritten. Also we should actually leave, probably this triggers some people, but we really shouldn't write stuff in C anymore. You would think you run some tiny little cute piece of dnsmasq software, and it's amazing after so many years of development, but yeah, not even the TFTP next token parsing is all right. So the simple fix probably would be, well, except not using C and writing this in Lua or even, I don't know what, Rust. Also, yeah, coming soon, rewriting Pulse audio and stuff in Rust or something. But anyway, even in C++ it would be nicer with std strings, of course. C++ not foolproof, but if you at least use classes that are there, like size, length included, size handling, string classes, and use iterators and parsing functions, you already avoid 90% of this kind of open-coded stuff. Speaking about open-coded stuff, I think if we do not want to rewrite this today, because all we wanted certainly was booting Linux on this nice little machine here, then probably its best thing is to rewrite this open-coded here. Open-coded meaning not using string lengths, because the problem is it's not even ideal, because if we need to scan, because as you see the string lengths, actually, you know what, we could use, does it exist string nlang maybe? Hey, it exists. So okay, fine, we could theoretically use string nlengths for size length limited stuff. So the problem with this kind of functions, some people always think, hey, just use the n family of functions and all your security issues go away. It's like obviously wrong. Depends on also surrounding code and error conditions, because you need to be careful checking here that it's not terminated. So if this is less than maxling, or maxling is, there is no null byte among the first maxling points. Stringling as if that is what is excluding, but at most maxling if it's doing this only at the first maxling bytes, and I think it probably returns, it's also, yeah, man pages, a little bit, yeah, live on YouTube, trying to decipher that. String angling returns stringling if that is less than maxling, or maxling if there is, okay, so it returns maxling. The problem is that we would need to, for maxlang, we would need to do some pointer arithmetic and subtract end minus the current p pointer here. Probably some people already tune out when I discuss here double pointers and pointer arithmetic, which probably want to share, like, and subscribe for some low-level programming series soon. In my opinion, probably it is not really the best to work with these boundary conditions here. Probably we probably could simply do this in one loop, which might be more readable than dealing with all the boundary conditions here of all the loop invariants and pointer arithmetic and reaching max length. So probably we want to increment, because you see we want to increment this pointer to the string buffer there. So we could probably rewrite this to if like one parsing loop, or again, you should not do this at home, use Rust and at least C++, which you could have done for 20 years already before Rust. But if you want to do this like this, then probably in one loop, checking here for the next null terminated thing. If we don't find it, return null. This is also, again, not recommended. Don't write C anymore. It probably again triggers people. So trigger warning, leave a comment below. But if you, for some desperate reason, need to do this in 2020, then do it here in one for loop scanning that and not fiddle around with stringling on whatnot in boundary conditions. But again, use memory safe languages, and at least languages that have some string class of probably handling string buffers, because yeah. So one for loop. So while we need the end condition. So while our p is not end, and at each iteration increment p, and then p here length plus 1. So the only, this is also tricky, we need to return this pointer to this string buffer so that it actually we could make this less, we need to be here careful. Yeah, you see live on YouTube, need to be careful. Actually, in general, it's also a good, many people often write, speaking about defensive programming, the topic of this video, you probably always, if your input buffer should always be smaller than the end, comparing not unequal. The problem is if you ever overrun this, you continue overrunning this forever until you hit the next segmentation fault. So checking that it's actually smaller than that is actually another way to avoid half of buffer overruns. Pointers, favorite subject of people in college. So let's see, can we make this halfway decent? I have the feeling with on the other hand, we don't really need to be that careful with updating this pointer to this string buffer, because in the case there is nothing to pass anymore. We return null anyway, so we only need to return something valid. for the case it is some usable null terminated token. So let's see. So save this for return. Save the beginning for return. Actually, the length we don't need then. Then until or as long as this is not reaching the end, check if. Also, yes, this was the old code. Then if we hit the null terminated buffer, so if this is a null terminator, then return the token. Here with our debug statement just for now. And then the next thing, so that then we return here the initially saved buffer. And the only thing is we need to make sure we leave this this pointer to the string pointer not pointing to the null terminator. So either I usually try to avoid invariance, but how do we make this best? We could actually the easiest thing would be, not the prettiest, would simply be to advance the pointer here as well. I don't like it the most, but that's what it is, because we are at the null terminator, and the next call to next should actually have this already not pointing to this null terminator anymore. So let's see, do we get here, is not so much to compute, it is not used. Writing C, probably nobody catches this live here on YouTube. I was thinking already whether the evaluation order, I think we yeah, this is a little bit tricky with this double pointer here. So this is a regular character, this is a regular string pointer. While this dereferenced, I think that should be what we want. We want, however, to increment. I wonder is because we want to increment. What is it even returning? No, it's returning our token, and the original code was incrementing. So yeah, this is a little bit tricky. This here increments the dereferenced. I slightly wonder whether we just can use +1, because the operator precedence apparently slightly wonder if that's hopefully, because probably operator precedence is fighting us there. Yeah, apparently that looks better. So did we maybe, oh wait a second, how many? Oh, only 200 frames. So let's see if that still works. Of course, theoretically we should invalid argument. What did we get now? Apparently we returned. Apparently it doesn't work. What is here our next? Unused. Where's even our next in this? Or actually, maybe we. Apparently already didn't work on the first try. But recurring theme here, this is somehow not my time best spent, but and also one of the really last things I will do at other people's C code, because that is not how we should spend our life in 2020. Oh, this returns something. Okay, so I guess, so this is, it returned our arcload econf, but didn't. What should we, how did this code work previously? File name next, and so this is calling next, and then directly next on this result. What did we do? No, wrong, but yeah, this is also a little bit the problem of this YouTube concept here of trying to finance open source stuff, and then it's so less interesting than people bicycling through New York and looking on real estate offers. So maybe we, wait a second, do we need to, okay, the original code actually didn't, we actually need to double dereferences because it is a pointer to a string pointer. I think we probably still have another bug in there, maybe. Oh no, we don't. No, it works, apparently. No, it works. So that is, yeah, pointers to pointers. Actually, funny anecdote in university, and then one of the first year or something, first or second year or something, maybe first year, in this do low-level C code, of course, the amazing stuff of probably first year, implementing some linked list or something in, was it C? Probably, maybe it was C, probably it was C. And I wrote this similar efficient of only using one double pointer to this list element, which nobody else did, probably all had like more management pointer stuff. And this was exactly with this kind of double dereferencing pointer stuff, apparently so confusing that even the tutor there didn't believe that this would work, but no, of course it did. Anyway, so let's see, what did we get? Next test, next octet, next 0, next. Does this make sense here? So we get a test, which also, yeah, this still doesn't load fully, because need to debug the bootloader more. There's still something strange going on. So let's see, we have here, apparently, this is returning still some next, because we had here indeed B1, which is plus minus F40, so that looks, maybe, does this look correct? This should, wait a second, this probably shouldn't return that though. So maybe there's still some, if it's smaller than end, why does it return? Oh, wait a second, this is misleading. This is only misleading output. So much to have your debug output also in order. Let's see, now we correctly also log, so we return next arg ecorf, octet and null, and so the code is not even less efficient because previously in terms of memory cycles spent on this, actually let's show you that. Speaking about efficiency, and people, yeah, but efficiency, no, because if the original code also had to iterate all over the whole buffer, it is only hidden here because, again, this faulty check of random garbage at the end. And then length of, so here in this code, the function, the next token parsing function calls out into string length on this red here. And so this string length iterates over the string until the null terminator. And so in terms of efficiency, maybe this is even slightly more efficient because it's not calling into some library function, which even if it's AVX512 accelerated, doesn't do much for the short strings that are not even aligned, because even if the whole buffer was quad word or something aligned for the latest and greatest AVX512 assembly, then latest here it's not aligned anymore, and then this short file names with AVX512 assembly for highly accelerated string functions don't even do a thing. And then this code here is even more efficient, and not that you needed the most efficient TFTP file name token parser, but in case you were wondering, that's how it is. Probably more readable in my opinion, simple iterating stuff, simply checking for the next null terminator, and if we don't find one, return null. Leave me in the comments below if that is more readable or isn't. We can also diff this nicely, so let's diff this here from dnsmasq original source TFTP to, so yeah, I should not have deleted that, but here we are. Yeah, plus some more. We are also great fans here of simply hand editing dnsmasq, hand editing this, so that would be TFTP next, I don't know, unfix. So what else did I add here? So this was the hex dumping, so obviously the hex dumping, we don't hex dump here the package, have here some open coded test stuff, and here is yeah, theoretically we could also, we should certainly send this upstream, because it's always nice if this previous video sending stuff to, I really wonder that there must be more people of Debian and Gentoo stuff who want to use dnsmasq, small, readable, but wanting this to boot on their vintage stuff. Do we also have this unsupported? Where would it be? Do we unsupported request here? Signed off by me, the fixer of all C code here live on YouTube. It's for me really depressive after 20 years in open source. You really would think this stuff should work by now, but you can't make this stuff up. It's hilarious. It's also hilarious that maybe there's a good reason. I think I could ask someone with access to, I think I know someone who might know someone who has the sources for the prom here. Maybe we take a look what the IRIX prom is even doing there. Maybe I can ask him if he can send me the tftp.c file over, for in case you were wondering how professional companies 20 years ago implemented this. It's of course hilarious that they send random garbage, but then again, defensive programming, you always need to account for random garbage, no matter what. The whole full stack from the lowest bootloader to your most fancy web server, because web browser. Defensive programming, and certainly why you don't want to write this in C, in not only in 2000 but 2020. I have some more stuff to debug. I'm actually here in the middle of debugging the bootloader, which, as you see here, I took already also somewhat over. In terms of also need to go home and walk around with our junior, because otherwise my wife is killing me soon for not spending too much Saturday with fixing C code of other people. But what I will probably do is reinventing the wheel and microkernel discussion stuff coming sometime soon, like really sometime soon, because this bootloader stuff here is also not the most well. It's arcload, so who are we kidding? And something is still going wrong here. So you see this now works. We get here this arcload ecof stuff for 32-bit arcs, and we also get here correctly with my other hack the other file, which also the upstream dnsmasq also doesn't obtain. Something is still going wrong there. I suspect maybe this is seeking, because this, and I can also show you where this is, that is in arc in loader main, and this is in elf whatsoever. I can also seek, so this is here in save the load headers in one of those here. And something is going wrong there. Also, yeah, just simply quickly booting your Linux on some workstations, like yeah, even the TFTP bootloader running havoc there. The issue here is somehow that this arc read here is returning 8. This 8, I checked this already also in some disassembly and standard stuff. Wait a second, 8 is arc read, so this would be arcs, and this is in arclib h of maybe even, which one was this? Was this arc h? 8 is it this, or maybe it is input output error? I need to check exactly which error that is, where it's coming from, but I suspect this is a seeking here, so I need to further debug this. Also, yeah, how can you spend an hour or two or whole afternoon or weekend debugging bootloader and TFTP stuff? So I get the stuff loaded, arc load anyway, and arc cf, but this load elf now fails, and so yeah, one step forward and one step back. I have the feeling either, so we read here, either the, well, it is also a little bit borderline of reading multiple things with TFTP, and then, because this, as you see, this TFTP protocol is like only read request one file at a time, so seeking is a little bit tricky, although certainly everything is possible to implement. So I guess there is something, well, obviously there is something going wrong, not yet sure where, whether the grub imported grub stuff here of this stuff, or at which step here in this fine software stack, fine arcload and arcs software stack is erroring out, because obviously this is one-shot loading over TFTP. If you implement file seeking, obviously backward seeking is a little bit, probably for backward seeking, either you buffer it a little bit, and if you backward seek too much, you would need to cancel this read request and start from scratch. And if it's seeking forward, then, which obviously here we mostly seek forward probably, and then for forward seeking you can simply skip some of this send bytes here by our dnsmasq TFTP server, but again, something doesn't work here. I need to instrument here some more stuff of logging what could possibly go wrong. But in any case, recurring theme, whatever we use and touch, at the end stuff is somehow more often than not failing and erroring out on us, and we need to apparently fix everything. But yeah, probably some more low-level programming coming soon. So probably some low-level how does machine language code stuff works. We had already a couple of videos if you want to watch them. In the meantime, instructions to architecture for RISC, ARM, MIPS and Spark. But probably we make a dedicated video how does this work low-level on the processors and low-level in the processor with machine code for all the people who don't learn this nowadays in the university anymore. Then C, C++, Rust, you name it, maybe also some fine dynamic script languages for the mix. Anyway, I got some stuff to do. I hope you learned something. Don't forget to share, like and subscribe to support me fixing all those bugs and features here in Can't Make This Stuff Up, every package we ever took a look at. And a recurring theme and reminder why you really shouldn't write anything in C anymore, because as you see, even the best of the industry, be it the Linux kernel, QLogic firmware, best of the industry, SGI, IRIX, ARX firmware, sending here random stuff, or your favorite dnsmasq stuff in your router, there are always bugs to leave behind and fix here live on this channel. That's mostly for this video. Let's take a final look at the comments. Did I say comments? I probably misspoke that again. Efficiency in this case doesn't matter much. You're not processing gigabytes of data. The Graver, you don't know what TFTP load here anyway, but yeah, as I said, doesn't matter, but it certainly should work, as I said. Since this patch, don't forget to the reviewed byline. Which reviewed byline do you mean? Do you mean you reviewed this? Should I attach your name, or which name do you mean there? In case I should attach there, reviewed by the Graver. The Graver's first thing he learned is never trust the input. Yeah, never trust the input, and also, yeah, shortcuts of there is a null terminator at the end of this message read request, certainly not when it's coming from fine SGI firmware. Anyway, Linux nerds write, if you write C, Valgrind is a necessity. Yeah, but you should not need, first of all, Valgrind doesn't catch anything, and you can't run Valgrind on your firmware here of this fine SGI firmware, nor on your kernel, which also case in point, right? Our microkernel idea, which we really should innovate soon. At least if you have user space drivers, you could in theory run Valgrind on your user space drivers, although you certainly shouldn't run them and write them in C anyway. But even we have seen this static checker for the Linux kernel with the big endian handling of our fine QLogic fiber channel driver. The static checker also probably need more coffee. The static checker didn't even check much of a thing and mostly produced false positives, and static checker didn't help much if these fields aren't even instrumented correctly, and each time you've seen this other, you run a static checker on your QLogic firmware stuff and it even warns about some locking, because that is so 2020. But also you shouldn't need to run other external memory heuristic checking things, probably with this track record of the IT industry, IT news and insecurity issues since 40 years and probably even more. By now we should have innovated to a case where when you write something, it is so well structured and memory safe that it works, like it compiles. And if this is like Rust or other higher languages, like did someone call out D or anything whatsoever, then it should not crash. But even Valgrind would not have found this bug, right? Because it's not only, it was not even buffer overrunning, right? It was just buffer null terminator checking of random garbage. And this is also probably, you want test cases, which probably this fine stuff, does it have probably 0 test cases, because anyway. But that's it now for today. let's see one last and anyway, the Graver, maybe you want to review this anyway, and you want to bless this patch with you're reviewed by. Joe writes, came late, arcload is byte serving files via FTP. No, not as, at least we are seeking. So this stuff does not yet work. So how do I spend my days and afternoons and nights and stuff with this exotic hardware? Yeah, the only one left who, also arcload. The only one left who is debugging arcload. Something still going wrong there. Do I also, yeah, this also works better if we have dnsmasq running. And at least probably the seeking is going wrong. Still need to debug what's going on there. And so it's not byte serving this, but reading this in blocks of 512 bytes at least. But whatever is going wrong with this seeking. Internet writes, browsers are the best OS. Yeah, but this is still like Emacs is an Emacs or systemd, the OS. You still have an kernel running below systemd or Emacs and or your browser. So, but it is a good point, and that is also one thing I'm wondering for the future of desktop operating systems in terms of our microkernel research that we should really start soon here. And that is certainly a good point. Nowadays you can't even write a totally amazing microkernel because at the end of the day you also need a totally freaking amazing browser, at least if you target the desktop. And even your most snappy and most responsive and memory safe microkernel doesn't help you much if at the end of the day you're running the same attack surface of Google Chrome or Firefox there on the desktop, and with anyway the performance issues and code bloat. And last but not least, the most snappy, super amazing browser doesn't help you much if the whole internet nowadays is so overloaded with dynamic HTML5, asynchronous JavaScript and canvas painting, WebGL and whatnot stuff, and megabytes of Node.js and other surrounding frameworks that it, yeah, your pretty fancy just-in-time compiling browser is busy parsing, just-in-time compiling all this fancy megabytes of JavaScript stuff, and some websites even loading Node.js multiple versions, some websites loading advertising trackers and whatnot, 20 of them, and then some of them, because they all come from different companies, each of them is loading their own Node.js or other similar frameworks like, yeah, performance and code size and network efficiency for what it's worth. Anyway, yeah, people agree there in the comments, Emacs and Vim are the best OS. That's it for today. I hope you learned something. I need to take care of our junior, and then later tonight or some other day continue debugging what is here with this arcload. Also, speaking about another one last, this is really the one last thing. Yes, there is grub2, which probably grub2 only supports, I think, 32-bit arcs maybe, so it would run on this SGI but not my Octane. But the other thing is, this is microkernel, but I will talk more about this in the really soon coming microkernel, more overview stuff. Also, if you are bored, in the meantime, there are already some microkernel design videos of years ago. But one thing is, I'm given this arcs load is actually not too large, and I would really, this it has the same issue. So the arcs load, of course, another as unsuccessful as our one-man stuff here of unmaintained and obsolete stuff. Not the most nice to fiddle around in this code, and somewhat also again not my time best spent. So what I really will do really soon, like a couple of weeks and months, in our microkernel design series, of course, write low-level code like hello world, of course, programming always starting with hello world. So hello world, bare metal coming soon, like bare metal, your first printf in your own DIY hobby kernel on PowerPC, Spark, MIPS, ARM, maybe x86 certainly, and this low-level stuff And our own microkernel, I'm somewhat tempted because the world certainly needs a new, another bootloader, because certainly grub2 takes over a lot of stuff, but grub2 is so large, not the most thrilled about that code base either. Previous video probably it was like 50 megabyte or something, and I'm not feeling like porting and maintaining grub2 on 64-bit ARCs, SGI ARCs for our precious SGI Octane, or this precious 32-bit ARCs, which maybe I should test if it works on this one. Maybe on this precious SGI grub2 actually might work, maybe. Maybe we should test this, but given this code base is so large, and C certainly, and you have seen how nice C code is here in 2020, right? That I'm somewhat tempted to write similar to our RISC-V FPGA firmware loading stuff there. More universal, reusable, tiny bootloader like think grub2, but in at least C++, if not Rust, and less pointer arithmetic, string handling, like more readable C++ strings or Rust code, and only the bare minimum debuggable and readable code there, maybe coming soon on Hello World, on all those architectures, similar to we have done already RISC-V firmware, more than Hello World, loading fancy video images and sound and executables there from our RISC-V FPGA from SD cards, previous videos. Anyway, that's it really for today now. Maybe see you later tonight or something. As usual, even if you watch this later, leave in the comments below what you think. See or not to see, that is a question, or for me actually, as much as it triggers some people, for me the answer is certainly no. Please no C anymore, no new C code anymore in 2020, as much as it triggers some people. At least C++ for sane strings, or otherwise Rust and other similar languages. One last look at the comments. What else do we have here? No time now, but which systems could IBM Petit Boot be ported to? As far as I've seen, so Petit Boot is a little bit misleading, right? No time now, but which systems could IBM? So Petit Boot is a little bit misleading, because Petit Boot is only using Linux, so you can only use Petit Boot for systems where you can directly load the Linux kernel, so this could be anything. So, but the question is it worth it? I'm also not really sure if I would call this IBM Petit Boot. I'm not sure if IBM did this. It was certainly developed in the context of the P3, previous videos, and they probably have done so that they do not need to write a driver and like hypervisor interface drivers for grub or yaboot, so that they only directly load the Linux kernel from, like, compile and link the Linux kernel so that it's a directly loadable ELF executable. Probably you could even do this on as ancient systems as this SGI stuff. Compile Linux kernel with all your drivers, have it certainly modify the kernel so that it is relocatable and kexecable. The only thing for Petit Boot you need is kexec, and theoretically maybe it could even work. The only problem is size. But if you want, if there is not a size limitation on ARCs machines like Sync SGI Octane or other such systems, the problem is a little bit size, because the Linux kernel, all the previous videos, gets a little bit large and out of hand. So for a somewhat reasonable system, you might have something of 16 megabyte for this kind of Petit Boot system of Linux kernel with surrounding programs in C library. Links this all together, the Linux kernel with initRD in one ELF executable and have it executed directly like a bootloader, very theoretically maybe even possible on vintage systems as JOctane and other such open firmware systems. But at the end of the day, I'm not really sure if it's worth it, but more to this boot structure, again, to the upcoming microkernel design series. But yeah, thanks for asking. That's it for today, and I hope to see you soon for all the next videos and live streams to come. And 279 drop frames, 0.2%, amazing. Today only with our failing DOCSIS cable.